Hello, Calculus, and welcome to 5.2. All right, so in these notes, we're going to talk about relative extremas, so minimums and maximums is what we're looking at, how to find them, and what they look like on the graph. So make sure you got 5.2 open, and let's go. All right, so when you're looking at relative extremas, the reason they're called relative is because a lot of times their graph will go on forever in one direction or another. So when you look at this graph, you can see that this will go down forever. I mean, there's absolutely no way there is a true relative min. And this one here also goes up forever, means there is no true relative max because it goes to infinity. But relative means on a certain part. So when you look at x1, this is the top of the graph, so that's a relative min. If you look at x2, this would be a turning point, so that is a relative, relative max, or min, sorry. Okay, did I go? Pause. Sorry about that jump. So x2 is a relative min. x3 again is the top of its section of graph, so it is a max. Note, there is no derivative at this point because it's a sharp point instead of a curved point. x4 is a relative min again. And we could go on forever. That's what goes in here. Min, max, and fill in as you go. So now when we go down here, we look at our graphs. Now, when we have extremas that do not end, so we will consider this guy a relative max or a min also. So this is the same. This is a max. This one's a min. This is a max. No derivative, by the way. This one here, since we are going down, he would be considered a min. Again, no derivative. Something to keep in mind. So now when we go here, our first derivative test, we look at the way it goes. If it's a positive or negative tells us if it's a max or min. So we're going to do the first derivative of our thing. If our first derivative is positive here, negative here, then our point is a max. If our first derivative is negative and then positive, then the point we're checking is a min. Okay? This here also shows you it could be positive, negative, and come to a sharp point. If that is true, there is no derivative at the point, but is still a max. It could also come to a sharp point, okay? Again, no derivative at that point, so it doesn't exist, but it is still a min. Here, if they are both positive, then it is not a min or a max. It's more like an inflection point. Again, here, both positive, same direction, nothing happening. When we go this way, if they're both negative, so if they match, again, this is not a min nor a max. Same thing here, not a min nor a max. It's either an inflection point or it does not exist. Okay, now let's go through our thing and see what this actually means. So we want to find the relative extrema, so our mins and maxes is what we're asking of x cubed, this x cubed function. We know it's a negative x cubed, so in our minds, we know this is opening something on this order. So our first one should be your min, and our second one should be a max. Now let's see if this plays out the way we think it should. So we do our first derivative. We get a negative x squared minus 4x plus 15. We're going to set this equal to 0. I factored out the negative 1. Now when you multiply, that's a negative 45. Well, factors of negative 45 that give you 4 are positive 9 and negative 5. Do your grouping, factor out what they have in common, and we come up with x plus 3 and 3x minus 5. Setting those equal to 0, we have negative 3 and 5/3. So these are mins or max points on our graph. So what we're checking is we have a negative 3 here and a 5/3 here. We need to know what our graph is doing. So the first thing we're going to do is pick points in between to check what they look like. So let's say we're going to pick a negative 4, probably a 0, and probably a 2. When we plug negative 4 down here into our derivative, not our original, our derivative, we get a negative 17. So negative 17 means it is going down. When you plug in 0, you get a positive 15. So this is positive, so it is increasing. So since this is negative and this is positive, negative 3 is going to be a min. When we plug in 2, we get a negative 5, which means that it is decreasing. Since this is positive and negative, that means 5/3 is a relative max, which is exactly what we thought should happen. To find those points, we need to plug them into the original function. So we plug them into f of -3. This is the original. And f of 5/3, again, the original. Using your table mode, we'll get a -26 and 67 over 20, which I calculated out, 24.8. Okay, so now we're going to graph those 2 points. So we're going to go to -3 and -26. Whoops, I'm sorry. And put our first point, -3, -26 is here. We're going to go to 5/3 and 24.8, which is here. Also, we know our y-intercept is 10 because it's the last value of our thing when you plug in x equals 0. So your y-intercept, you let x equal 0, which gives us 10 for y. And then we just sketch in our graph. We know this is a min, this is a max, and we draw it as so. I hope that worked well for you. Okay, it's your turn. So pause and give yours a shot. First thing you could do is actually graph the y-intercept. When I look at this and I see my y-intercept is 15, this is kind of an issue because my graph only goes to 9. So I think I'm going to go by 5s here. So I'm going to change this to by 5. So hopefully it fits a little better. So 5, 10, 15, 20, 25, 30, 35, 40, 45. It's not going to be enough, but at least it will be better. So step 1, we found our y-intercept and it equaled 15. Now we want to do our first derivative, which equals 6x squared minus 6x minus 72. Why I put 17, I have no idea. All right, I'll set this equal to 0. Everything's divisible by 6, so we can get to 6. 0 equals, excuse me, x squared minus x minus 12. Factors of 12 that give us -1, or x minus 4, x plus 3. So we get x equals 4 and x equals -3. Also, I forgot to draw my original. It's going to end positive, so I think it's going to go like this. So my first one should be a max and my second one should be a min. Let's see how we're doing here. So we're going to go through -3 and 4. Let's plug in 0, -4 and 5. Okay, we're plugging this into f prime, remember? So when we plug -4 into f prime, so f prime of -4 is what you're doing up here, where you're plugging it in, or here, does not matter. You're going to get a -0.29. So it is decreasing. When you plugged in 0, you got oh, I'm sorry, that was 48. Looked at the wrong graph. Sorry, children. Here we go, that's better. Okay, when you plugged in -4, you got a positive 48. So he is increasing. When you plugged in 0, you got a -72. So he's decreasing, which means -3 is a max, which is what it should be. When you plugged in 5, you got a positive 48. So he is increasing again, which means 4 is a min. Now we actually got to find those points so we can graph them. So we're going to plug it into our original, f of 3, -3, and f of 4. Okay, f of -3, you should have plugged that in and got 150. F of 4, when you plug that in, you got a -13. So let's graph these on a graph. So f of 4 is a -13 since we're going by 5s. That's roughly here. -3 is a positive 150. That's like way off my graph still. I'm just going to label that at 150 and draw in X-intercept is 15. Draw in our graph, which is exactly what we thought it should look like. So we did well. Okay, let's continue on. All right, different situations. So remember before we talked about ones that had points that came to points in the graph? That's kind of what we're looking at here. So decimals sometimes to help. So if you have decimals up, I'd plug this in so you kind of get an idea of what you're looking at. If not, that's okay too. So first thing we look at is my y-intercept is 0. When I plug in 0 for x, I get 0. So 0, 0 is a point on my graph. Okay, next thing we have to do is find our first derivative. Well, when we do this, 2/3 times 6, so divided by 2, that should be 4x. Now, 2/3 minus 1 is a negative 1/3. We'll deal with that in just a little bit. Minus 4. So the negative 1/3, we have to set this thing equal to 0 to solve it. So now we got 4x to the negative 1/3 equals 4. So x to the negative 1/3 equals 1. Doesn't matter what we do, so we're taking the negative cube root. So x is still equal to 1 because any root of 1 is 1. So now we got x equals 1. We also have the problem that it says x cannot be equal to 0 because this technically is 1 over x to the 1/3 power. All right, well, this here cannot be equal to 0 because if that's equal to 0, we're dividing by 0. So 1 is one of my answers, and we also know that x cannot be equal to 0. But we just found that the y-intercept was 0, 0. So what this means is at 0, there is no derivative. Okay, since I know I have a point at 0, it's not an asymptote, which means it's a point on the graph. So it either ends there or it goes like this or something on that order is what we're looking at. So we have to figure out which one of these it is. So in order to do that, let's go here. We're going to check. So we got f of 1, f of 0, and we need to figure out what's going on in between. So when we look at these things on our graph, we got to figure out maxes and mins, right? So the point I have to worry about is 0, because I know that's bad, and 1. So we're going to plug in things on each side. So we're going to plug in -1, 0.5, and 2 into my derivative. So when I do f prime of -1, I plug -1 up here, you're going to get -8. Right? Because the cube root of -1 is -1, -4, -4 is -8. So this guy is decreasing. Okay, we're going to plug in 0.5, and when you do that, you get 1.03. Positive, so this guy is increasing. That means 0 is a min. I also know it's a weird point. I plug in 2, and I get -0.8. So that means this guy is increasing, which means 1 is a max. Not bad so far. So let's figure out what these points are. So now we've got to go to our original. So now we're at our original. Using your table, we'll do f of 1, which really isn't too hard this time. 6 minus 4 is 2. So we're going to go to 1, 2, and we put a dot. Okay, I know that that's a max. And then when I go and I look at 0, I know that's a turning point. All right, I know this is a min, so I have to be going down to this, back up to my max, and turn back around. That is a rough sketch of that graph. Kind of cool. I hope you enjoyed doing that one. All right, next one. We had x cubed and e to the x. If you did not do this, pause and do it. All right, hopefully you did. So again, when you do the y-intercept, When we let x equal 0, well, that's 0 times e to the 0, which is still 0. So my first point is 0, 0 again. All right, so I know it's a point on the graph. So now we're going to do our first derivative. Now, let's see if you remember how to do that. So you do the derivative of the first, which is 3x squared times the second, plus the derivative of the second. Remember, the derivative of e to the x is just e to the x times the first, which is x cubed. So when I look at this thing, we're going to factor out what they have in common, which is x squared e to the x. So if I take out x squared e to the x, that leaves me with 3 plus x. All right, a little bit easier to set equals 0. So when we set this equal to 0, this first term is going to be 0, which we already know because 0, 0 was one of my points. Okay, and my next one is x equals -3. So -3 is either a min or a max, and 0 is either a min or a max. Again, it's probably going to be one of those weird turning points. We got to figure out what's going on. So we're going to do our graph again. We're going to put -3, 0. Now we got to pick points to check. So let's do -4. I just picked a -2. It doesn't really matter. -2, -1 will give you the same result. And 1. Okay, when we plug in -4 to f prime, so you do an f prime of -4, so you're plugging it in up here. When I plug that in using my table, I got a -0.29. So this is going down. When I plugged in -2, I got a positive 0.5. So this guy's going up. That means -3 is a min. Okay, when I plugged in 0, I got a positive 10. So this guy is also going up. Now remember from our ones before when they went up and up, this was like an inflection point. It kind of met and went through. So that's what's going to happen at 0, 0. But now we got to know what those points actually are. So let's plug in to your original now is where you're at. So we're going to put original, f of -3. Okay, using your table mode, I got -1.3, and then f of 0. Using your table mode again, you got 0, which you should have already known. Okay, so we got 0, 0. We got -3, -1.3, which is down here. We know that's a min. So this is going down to this point, back through to 0, 0, but it continues to go up. So it looks something like that. Down to here, through here, levels off and continues up. So it's increasing, increasing. All right, I hope you did well. Technically, that's not what this graph looks like. I don't know if you used your Desmos or not. I kind of wanted to show you the real one. If you would have plugged in more points or used your table mode, you would have seen that it kind of follows that there, goes up, oh, and then I missed. All right, let's do it again. So it follows like an asymptote at 0. Okay, turns at here, goes back up here, and then back through. So it levels off right here. Wonder why that happens. Any idea? I hope you're thinking about it. Okay. If you would have drawn it the first way, I would take that because that's information you actually don't know yet. But the table on your calculator, if you went to the auto mode, would have shown you that it approached 0. So I'm hoping you're using that. Okay, bicycle sales. Let's add a little bit of stuff to this guy. So now when we look at bicycle sales, we're going to give you the cost function, which is right here. So we got the cost function and we got the demand function. Remember, demand is P. Okay, P is the price per bicycle. So the demand and price are the same thing. This is the cost. Now to find revenue, so remember revenue is how much it costs times your quantity. So we got to take the 90 minus Q times how many we sell. And this is my revenue function. Now if I want to find max revenue, I haven't used the cost yet, max revenue, I just do the first derivative. So 90 minus 2q, set it equal to 0. And at 45, there's a critical point. All right, so if I check, so if I go on my number line and I put 45, and I just picked two numbers. I picked 40 and 50. Okay, 40 was a positive 10, so this guy was going up. 50 was a negative 10, so this guy is going down, which means 45 is a max, which is exactly what I want. So now I plug 45 into my original right here to find out how much money I'm actually making, and I'm making $2,025 when I make 45 bicycles. It's the most money I will make. Okay, max revenue. Now let's talk about max profit. So remember profit, profit is revenue minus cost. Hopefully we can get back to here quickly. We don't have, okay. So revenue minus cost. So I took my revenue function, which we found above, minus the cost function that we hadn't used yet. All I did here was distribute the negative and combine like terms to get to this equation. Now to find max profit, again, it's a first derivative. So to do the first derivative of this function, we got negative 1 over 20, q squared minus 2q plus 85. All right, that is not going to solve pretty. It doesn't factor, it doesn't do anything. So we're just going to use the quadratic formula. So you're going to say q is equal to the opposite of b, plus or minus the square root of b squared, minus 4 times a, which is 1 over 120, times c, all over 2a. Type that, that's a negative 1 over 20. Type that into your calculator, and you're going to get 25.8, and then the negative is going to be 65.8. We cannot have a negative number bicycle, so that's impossible. So now we got 25.8 to consider. So when do I make my most money? And I can't make 25.8 bikes, right? So we have to plug in, again, if you plug in the 0 and the 31 on each side, you'll find that this is a max. But now I got to plug in the numbers between 25 and 28. So I got to plug in 25 and 26 into my original to see which one actually gives me the max profit. Well, when you plug in 25 to your original, you get $1,229.58. And when you plug in 26, you get $1,231.07. So I'm going to make my max profit at 26 bikes, which you could have seen because 25.8 is closer to 26 than it is to 25. Is another way of knowing that. Either way, you have to plug it in to find your max profit. All right. When you look on the next page, find the price to reach the max profit. This is just showing your two things. All right. So we have profit function, which is right here. So here's revenue. Okay. And here's cost up here. So revenue is this one, cost is this one. Okay, profit, remember, is revenue minus cost. Well, when you take the revenue, this guy right here, minus the cost, it's the part where they're the farthest apart is where your max profit occurs. All right, when you look at this, what do you notice? Anything interesting, I'm hoping? Right here's your break-even point. Here's your 26. This is when it's the most apart. Life is good. All right, here we go. I want you to find the max profit and what the company should charge to obtain the max profit. So pause this and do this problem. Okay, I just wanted to talk for a little bit while you were working. When you looked here, the first thing you should have done is find your revenue, because without finding your revenue, you cannot find your profit. I did not ask for max revenue, so we do not need to find its derivative, but I do need the revenue to find profit. Okay, so you found your revenue equation, and then your step 2 was your profit equation, which is revenue minus cost. So 50q minus 2q squared minus 100 minus 10q. I just distributed that negative through. Okay, combine your like terms and put them in descending order. So we got negative 2q squared minus 10, plus 40q, sorry, minus 100. All right, now to find the max revenue, we have to take the first derivative, or max profit, we have to take the first derivative. So your third step was to find the derivative of your profit function, which was negative 4q plus 40. Should have set that equal to 0. So when you solved, q is equal to 10. Okay, when you plug numbers in, so you're checking, we have 10. If you plugged in 0 and 20, you plugged in 0, you had a positive number, so it's increasing. You plugged in 20, you had a negative number, so it's decreasing. So it truly is a max profit, which is what we need to find that profit. We take the 10 and we plug it into the original. I'm running out of room. So we take P of 10, which is this guy right here, which is equal to 50 times 10 minus 2. Oh, I should have used the bottom one. Oh well. Times 10 squared minus 100 minus 10 times 10. Okay, when you plug that all in, you would have gotten 100. So when you're producing 10 items, you'll make a max profit of $100. Any questions? Why do you think we should charge $30? Any idea where that comes from? It's from up here. So when you take the 50 minus the 2 times the 10, this equals 30. That's the cost you should plug in. A very good thing to know. All right, so that's your price. So you're charging $30, you're producing 10 of them, and you're going to make a profit of $100. All right, good luck on your homework. I hope you do well.